In this video, we are going to learn Liskov Substitution Principle, that is LSP from solid principles. So it is one of the solid principle. Okay, so let's get started. The Liskov Substitution Principle (LSP) is one of the solid principles in the software design and was introduced by Barbara Liskov. It states that objects of superclass should be replaceable with objects of subclass without affecting the correctness of the program. Did you get it? It states that objects of superclass should be replaceable with objects of subclass without affecting the correctness of the program. We are going to understand this with example, so don't worry. In other words, a derived class should be able to substitute its base class without altering the behavior of the program. The LSP is closely related to concept of polymorphism and inheritance in object-oriented programming. When adhering to LSP, the following conditions should be met. So there are two conditions need to meet for the LSP Liskov substitution principle. So let's understand first one, behavior preservation. Okay, subtypes must provide the same behavior as the base types. Clients using instances of a base class should be able to use instances of derived class without knowing it. Then we have consistent inheritance. Derived classes should not override or modify the behavior of base class in ways that would surprise or break the functionality of program. They should extend or specialize the behavior, not alter it fundamentally. Here is example in C++ to illustrate the Liskov substitution principle. So let's understand with example. This is one example I have written here. In this example, the bird class has a fly method. Here we have bird class which has a virtual fly method. Okay. The penguin class inherits from bird. Penguin class is inherited from bird. Okay. So this is base class and this is inherited class. This class name is penguin. It is inherited from public bird. Okay. But overrides the fly method to indicate that penguins cannot fly. So we override the fly method from base class. Here we have fly method. Penguins cannot fly, so we override the fly method and we have written here in the function that is penguins cannot fly. Okay. The perform flight function takes reference to the bird. So this is perform flight function that demonstrating LSP by using bird reference. So we are taking object of bird here. Okay, it's bird class and we are taking the object of bird as an argument. Okay, it demonstrates that it can accept both bird and penguin. The behavior is consistent with the expected behavior of each type. By adhering Liskov substitution principle, the program can treat objects of the derived class, that is penguin, as objects of base class, that is bird, without introducing unexpected behavior. This helps create more flexible and maintainable code. If we can see, we called this function two times, perform flight. But first time we are passing the object of bird, okay, that is bird class which is base class, and second time we passing the object of penguin class, that is derived class. So using LSP, a function expecting a bird can also accept penguin. Here we are expecting bird class only, but we are accepting penguin as well. Okay, so let's run this and find if it's working well. Click on local Windows debugger. So as per our definition, we we are calling function two time, first with bird class object, that is base class, and second with penguin class object, which is derived class, and we are achieving same behavior. So program is running successfully, and let's see the result. Yeah, it's loading now. Okay, first time we passed bird. Okay, and we are calling the function from bird class, that is fly. Here a bird is flying. We use this function call. So, oh sorry, this one, a bird is flying, we can see this. Then we passing, wait a minute, we passing the penguin class to the this function, and we are getting result here that penguins cannot fly. Okay, so this is how Liskov substitution principle works. We can revisit it again. It states that objects of superclass should be replaceable. So here, object of superclass, it can be replaced with object of derived class. Okay, replaceable with the objects of subclass without affecting the correctness of the program. In other words, a derived class should be able to substitute its base class without altering the behavior of program. So that's all for Liskov substitution principle. If you have any questions, add in the question section. Thank you.